After studying this module, you shall be able to know about the basic of forensic photography, selection of photographic lenses. The word photography is derived from Greek word photos, which means light, and graphos, meaning pertaining to drawing or writing. Therefore, photography can be defined as the art, science, and practice of creating the durable images by recording light or other electromagnetic radiations, either chemically or by means of light sensitive materials such as photographic film, or electronically by means of an image sensor. In crime cases, the documentation of evidence is one of the most important stages of any crime scene investigation. Besides other, photography is considered as one of the important documentation techniques in the field of forensic science, which can record an whole crime scene area, exact conditions of crime scene, and the evidences present over there. The photography is also sometimes used to further enhance the details that are being visible to the human eye. The forensic photography section supports the forensic science in general, but to various divisions like question document, chemistry, toxicology, ballistic, physical section, biological section, DNA, and medical examiners department by documenting the evidences, crime scenes and autopsies, etc. The photography section of any laboratory is also responsible for the design of display and graphics for reports to be presented in the court of law, training and the web. So this division is considered to be an essential part of general crime scene investigation and thereafter in the laboratory. In addition, it is often used in the laboratory to visualize and store the patterns and phenomena that sometimes might not be detectable with naked eye. This application of photography in forensic science is based on the fact that it can be done in different spectral regions like ultraviolet and infrared rays.
Now, the light sources. There is need to understand the concept of light and their types to understand the photography. Light or visible light is a narrow region of electromagnetic spectrum. The electromagnetic energy with wavelengths within the range of 400 to 700 nanometer is capable of stimulating receptors, rods and cones in the retina of the eye, and for this reason is known as visible light. When light falls on the object, the visual and photographic images are produced by gathering a portion of the light emitted or reflected by an object and resembling it to form an image. When light interacts with object, sometimes it gets transmitted in case of transparent objects and other times it gets reflected when there is an opaque object. The way in which the light has interacted with the object helps in getting information about the resembling of the light to form an image. Illumination or lighting conditions. Illumination or lighting conditions makes a significant difference between a photograph which is of good quality and the photograph which is of poor quality. When the natural light is not sufficient or it is not available, then we have to opt for artificial light. Artificial illumination sources include arc light, flash bulbs and electronic flash, etc. They can be moved and positioned accordingly so that various angles of illumination can be obtained. Control of the illumination angle is difficult when available light such as sunlight or normal room light is being relied upon for the exposure. Thus, Artificial illumination is preferred when control of the angle of illumination is important. For this, one should try different angles if it is not sure which of the illumination angle is to be used. In this table, frequency and wavelength of electromagnetic spectrum is given. In this table, the name of radiation, its frequency in hertz and wavelength in meter is given. First is the gamma ray, whose frequency is 10 to the power 21 to 10 to the power 19 and its wavelength is more than 10 to the power minus 12. Next is X-ray, whose frequency is 10 to the power 19 to 10 to the power 17 and its wavelength is 10 to the power minus 8 to 10 to the power minus 12. Now the third is UV rays, whose frequency is 10 to the power 17 to 7 into 10 to the power 14 and its wavelength is 3 into 10 to the power minus 7 to 3 into 10 to the power minus 7 to 3 into 10 to the power minus 8. Next is visible rays, whose frequency is 7 into 10 to the power 14 to 4 into 10 to the power 14 and its wavelength is 8 into 10 to the power minus 7 to 4 into 10 to the power minus 7. Next is IR rays, 4 into 10 to the power 14 to 4 into 10 to the power 12 and its wavelength is 10 to the power minus 3 to 8 into 10 to the power minus 7. Next is microwaves, whose frequency is 10 to the power 12 to 10 to the power 9 and its wavelength is 1 to 10 to the power minus 3. Next is radio waves, whose frequency is 10 to the power 9 to 10 to the power 7 and its wavelength is less than 1. The electromagnetic radiations other than visible light, which are called infrared radiations, was discovered by William Herschel in 1800 when he was checking the temperature of various colors of the spectrum by splitting through the prism. He observed the highest temperature away from the red color. Then he suggested a theory that change of temperature was due to a type of calorific rays or light rays that could not be seen. Immediately in the next year, John Ritter, while working on the other end of the visible spectrum, noticed chemical rays later named as ultraviolet radiations, which are also invisible light rays but induce certain chemical reactions. These were beyond visible spectrum and behaved similar to visible violet light rays. Ultraviolet light has shorter wavelength than the shortest visible wavelength, but infrared light has longer wavelength than longest visible wavelength. These two lights, UV and IR, do not fall in the sensitive level of the human eye, which varies from 400 to 750 nanometer, but still have important applications in forensic examinations of clue materials at crime scene and in the laboratory as well. Photographs has to be taken on a special film with these two lights, UV and IR, and reveals different properties of different types of physical evidences like cement stained garments or bed sheets, caution documents including obliterated writing and GSR discharge, etc. Now the table is showing major colors and their complements along with wavelength. In this, wavelength range in nanometer is given, is color and its major components. The wavelength range of 400 to 450 shows violet color and its major complements are yellow and green. The wavelength of 450 to 480 shows blue color and its major complements are yellow. The wavelength of 480 to 490 shows green blue color and its major complements is orange color. The wavelength of 490 to 500 shows blue green color and its major complement is red. The wavelength of 500 to 560 show green color and its major complement is purple. The wavelength of 560 to 575 shows yellow green color and its major complement is violet. The wavelength of 575 to 590 shows yellow color and its major complement is blue. The wavelength of 590 to 625 shows orange color and its major complement color is blue-green. The wavelength of 625 to 750 shows red color and its major complement is blue-green. Now the contrast. Contrast is the degree of difference between black and white or dark shadows and bright highlights of the photograph's images. Without contrast, there wouldn't be any difference between dark and bright light. There are two types of contrast in photography, high contrast and low contrast. An image is said to be in high contrast when it exhibits a full range of tones ranging from black to white, and strong, bold colors and textures of the images are emphasized. On the contrary, in a low contrast photograph appears dull as it doesn't exhibit a great deal of difference between its darks and lights. Best examples of low contrast are the photos taken in the fog or mist. Contrast in forensic photography is very important. Light sources play a significant role in providing contrast. Angle of incident light is one parameter that can be different. In a unidirectional light source, the light is subject from one direction only, which gives too much contrast or shadowing. In such situations, source of diffuse illumination can be selected, which can be obtained by placing a translucent material such as a thin white paper or ground glass in between the source and the subject to scatter the light and act as a diffuser and further help in the reduction of shadow contrast. Next is the filters. Filters are camera accessories which modifies the image recorded, maybe on any recording medium. Sometimes they are used to make only minor changes to images, other times they need a major changes in the images. Colored filters play an important role to get the selected color and further enhancing the contrast of an image. When placed over the light source or the camera lenses, an object will appear darker in the photograph if the filter of complementary color is used. For example, if a filter of the same color is used, then the object appears comparatively lighter. If filters of black and white film are used, then they are called color contrast filters. The filters which is to be placed over the camera lens must be of higher quality, but there is no such requirements in case of white light source. Filters also changes the color balance of images, so photographs taken under incandescent light source shows color as they are perceived rather than a reddish thing. There are filters which distort the image as desired, diffusing an otherwise sharp image, adding a starry effect, etc. Supplementary close-up lenses can also be used as filters. Now, temperature and color balance. It is well known that white light is made up of all the 7 colors of visible spectrum. The color of the white light used in color photography is critical. Color contrast filters are required for black and white photography. However, all sources of white light are not the same. For example, the light given off by a candle contains a higher proportion of the longer wavelength corresponding to yellow, orange and red color. Hence, light appears yellowish or yellow-white. The light produced by a tungsten filament in a normal incandescent lamp bulb also contains a preponderance of longer wavelengths, although to a lesser degree. This light appears whiter than that forms the candle flame, but is noticeably yellow as compared to sunlight. The tungsten filament is hotter than the candle flame. There is a direct correlation between the temperature and color balance. For example, the hotter and incandescent light source, the whiter the light it will produces. This relationship between the color of the source and its temperature specify the degree of whiteness of the source by comparing it to the color of the light emitted from a standard source. To prove, when an experiment was conducted by matching the colors of the two sources by adjusting the temperature of the known standard source in Kelvin scale K, which is a measure of the color temperature of light, or in other words, the degree of whiteness of the unknown source. The numerical values are called the color temperature of the source and are given. Electronic flash has approximately 6000 Kelvin color temperature, whereas the photo flood bulbs professional tungsten have 3200 or 3400 Kelvin color temperatures and 5500 Kelvin for daylight. Sources with color temperatures other than 6000 Kelvin can be utilized within daylight films if special filters are used to change the color temperature to 6000 Kelvin. The filters are known as color correction filters. The Kelvin scale K has little value, as color correction filters are identified by non-standardized numbers which vary from manufacturer to manufacturer, because it runs counter to the way in which we use some photographic terms. For example, in photographic terms, when a photographer talks about adding warmth to a scene, which usually means to add some reddishness tone. On the other hand, when photographers talk about cool tones, they are referring to the bluish side of the spectrum. This logic is just the opposite of the Kelvin scale of color temperature. The need of these filters have been greatly reduced by the widespread adoption of digital photography, since color balance may be corrected with camera setting as the image is captured or by software manipulation afterwards. Now, the lenses. Some of the lenses are fixed permanently on the camera or sometimes interchangeable with lenses of different physical properties like focal length and apertures. Lenses used in still and video camera are more or less same as used in microscope or a telescope. Their detailed construction is different. A camera lens or photographic lens, either individually or assembly of lenses, are capable of making image on either photographic film, chemically, or presently on any other media, hard disk or card, electronically. The image formed onto a film in a camera is a real image. As the latent image formed on the film is affected by the spatial variation of intensity, the treatment with developer and fixer chemical make the latent image permanent. The following factors contribute significantly in the selection and use of photographic lenses. Now, focusing. Focusing of a camera is accomplished by altering the distances that separates the lens and the film. In this, for a distant subject, this separation should be little more than the focal length of the lens. If the subject is at infinite distance with respect to the focal length of the camera lens, in a case parallel light is brought to focus at the principal focus of the lens. Next, for objects closer to the camera, the lens must be moved further from the film to produce an image. Now, selection of photographic lenses. In this, the first is lens types. The quality of camera depends upon the type of lenses used. The better quality camera often have complex lenses. These lenses are made up of a combination of individual lenses as various elements mounted together. These assemblies are called multi-element lenses. The additional elements are sometimes necessary to make this lens perform more closely to a hypothetical ideal lens. Now, the focal length. Focal length of a lens is one of the major parameters to select the lens for a particular type of camera and photography. Focal length can be defined as the distance from the lens and a point where the parallel rays of lights come to meet. Particular type of lens can be selected for a particular type of camera used for a particular type of photography. There are three general classes of lens which can be distinguished on the basis of their focal length. These are the normal, the wide angle and the telephoto. The first, normal lens. Focal length. These lenses are approximately equal to the length of the diagonal line drawn between opposite corners of the picture area on the film. A normal lens cannot focus much if tried from a distance. For example, if we need to focus the interior part of a room, it has to be focused from a closer distance. Next is the wide angle lens. Lens with focal length substantially less than 45 mm, particularly when they are used on 35 mm cameras, are known as wide angle lenses. These lenses provide a wider angle of view than a normal lens. Wide angle lenses are particularly useful for making overall photographs in the cramped quarters that are typical of making indoor scenes. Now, the telephoto lenses. Focal lengths, these lenses are longer than the normal, have narrower angles of view but yield larger images of distant object. A telephoto lens may be used to produce an enlarged image of a remote or inaccessible object from a reasonable or more convenient distance. The normal and wide angle lenses are sufficient for most crime scene situations. Telephoto lenses are less commonly used for taking photographs of subjects at moderate to far distances. True zoom lens is par focal lens is one of that maintains focus when its focal length changes and is available for most 35 mm cameras. These are complex lenses with provision for moving certain group of internal elements so that the focal length can be varied continuously. The image quality produced with zoom lenses is generally not as good as with high quality fixed focus lens. This lens should have micro capabilities so that close-ups of evidences at crime scenes can also be taken. Now, lens speed. To select a photographic lens, the second main descriptive variable is its speed. Lens speed refers to the maximum aperture diameter of photographic lens. The aperture of a lens can be defined as the diameter of the open circle or diaphragm inside the lens. This diameter can also be expressed in the form of f number such as f by 2.8 or f by 16. Lens speed is to measure a power of a lens to gather light. Two lenses with same focal length can have different speeds. When both are used under identical conditions, the speed of a lens is related to the maximum size of its opening or aperture. Larger the aperture, faster will be the speed of the lens. A lens with a larger maximum aperture or a smaller minimum f number is called a fast lens, as it delivers more light intensity to illuminate the focal plane, achieving the small exposure with a faster shutter speed. It also requires reducing interference from exogenous noise, which means lower the noise floor. A smaller maximum aperture or a larger minimum f number is a slow lens as it delivers less light intensity, which means has a higher noise floor and requires a slower shutter speed. Lens speed has importance while taking the picture in dim light. It has also importance in taking pictures with telephoto lens, in controlling depth of field, especially in portrait photography. Next is with respect to key variables in combination with other variables such as focal length and camera format size. Now the summary. The word photography is derived from the Greek word photos mean light and graphos mean pertaining to drawing or writing. Therefore, photography can be defined as the art, science and practice of creating the durable images by recording light or other electromagnetic radiations, either chemical by means of a light sensitive material such as a photographic film or electronically by means of an image sensor. Contrast is the degree of difference between black and white or dark shadows or bright highlights of a photograph's images. Without contrast, there would be any difference between light and dark. There are two types of contrast in photography: high contrast and low contrast. A camera lens or photographic lens, either individually or assembly of lens, are capable of making image on either photographic film chemically or presently on any other media, hard disk or card electronically. Some of the lenses are fixed permanently on a camera or sometimes interchangeable with lenses of different physical properties like focal length and apertures. Lenses used in still and video camera are more or less same as in the microscope or a telescope. Their detailed construction is different. Two lenses with same focal length can have different speed. When both are used under identical conditions, the speed of the lens is related to the maximum speed of its operating or aperture. Larger the aperture, faster will be the speed of the lens.